this video we are going to exploit one of the most common vulnerability that you can find in a CTF. Let's try to solve the first challenge of this website. We can download the binary file and then later on connect to this address at this port to get the flag. Now that we have the binary file, we can run it and see what it does. In our case, this seems to do nothing in particular. It just print a message and then ask for some kind of input. I use IDA-Pro to analyze the binary file, but other tools are also fine. After opening it with IDA, we can see that it's a pretty short program. It puts some values on the stack and does some syscall. The problem is to find the vulnerability and to exploit it. The most common way to do it is to feed some input to the program until it crashes, and then from there identify the bug and exploit it if possible. Since in this case we don't have a lot of instruction, we could use a static approach to find this bug just by looking at the assembly code. Let's analyze step by step the flow of the program and draw the layout of the stack. So the first instruction, put the ESP register into the stack. Then another address is put into the stack. This is the address of the exit subroutine, a bunch of XOR instruction that sets the values of the register to 0. Some other values are put into the stack. Those are the character of the message that will print the following syscall. Then we have the write syscall that prints the first 20 bytes of the stack. And then we have the read syscall that waits for up to 60 bytes from the user. After the read syscall, we have this add instruction that it's basically deleting the characters of the string from the stack. And in the end, we have the return instruction that will update the instruction pointer with the first value into the stack. So the program will jump to the exit subroutine. If you look more carefully to the read syscall, we can notice that the ECX register holds the value of the ESP register. So the user is putting up to 60 bytes into the stack. And this is the bug. The user could overwrite the exit address by inserting a string long enough as input. Now we could start analyzing the program using a dynamic approach, but I think that in this case it is not necessary. Let's take a look at the layout of the stack when the user inserts a message of 60 characters. After this is called, the layout of the stack is the following, and updating the stack pointer with the add instruction will delete just the first 20 bytes of the input. So the instruction pointer will be updated to this value, and the program will crash because it's trying to jump to an illegal address. Supposing that the stack is executable and that we don't have any kind of security protection, what we want to do is inject some malicious code into the stack and then redirect the instruction pointer to it so that our code will be executed. But to do that, we need to know the address of the stack. We can lick the stack pointer by jumping again in the write syscall and print the first 20 bytes of the stack. Of these 20 bytes, we are interested only in the first 4, since those represent the address of the stack. Using the analysis done, let's try to write an exploit to run command as a root user. I'm going to write the exploit in Python, but you can use your favorite language. It doesn't matter. We need to use some common library to connect to the server and to pack data into bytes. And after checking that everything works, we can write our payload. 20 bytes for padding so that the next value, that is the address of the write syscall, will overwrite the address of the exit subroutine. Now the next 4 bytes received from the server will be the value of the ESP register, and using this we can write the final payload including the shellcode, because now we have the stack address and we can jump to it. I'm also adding the line that will run the command on the server to get the flag after the execution of our code into the stack. To generate the shellcode, we can proceed in 2 ways. One, we copy it from the internet, or we write it. Let's try to quickly write it. We want to execute the system call exceed with argument bin sh. To do this, we put the string into the stack and we set the values of the register in a proper way, and then we use the instruction in it to execute it. After compiling and creating the binary file, I use object dump to get the opcode generated, and now we just need to paste the shellcode into our script, fix some bugs, and run it.